Welcome back, everybody, to Digital SAT Math Crash Course. This is day one. We're on part two, coming back from a little break. And we're going to continue rolling here with using this Desmos calculator to simplify a lot of these digital SAT math questions. We got a new question up on the screen. We got, an equation of the circle question going on here. I don't remember who we ended with last time. Let's just start again with Ruby. Go ahead and read question 23 for us, and we'll discuss solving this one together.
What is the diameter of the circle in the xy plane with equation?
Yeah, that equation. That mess. Yeah, don't worry about trying to read that. Okay. Ruby, how familiar are you with graphing circles in the xy axis? You familiar with that?
I am slightly familiar.
Yeah. I'd say most students are kind of in that camp of slightly familiar. There's a way to do this, a way to sort of like interpret this equation, and like you can draw out the center point of the circle and figure out what the radius is if you can kind of interpret it the right way. And on the old SAT, you had to do that because you'd see these questions sometimes on that section 3 without the calculator, right? Mm-hmm. But we don't need to do that anymore on the digital test. We can just graph it, right? Like it'll give us a circle and we'll just see what the diameter is, right? Does that make some sense?
Yes.
Okay, great. We're gonna do that here in just a moment. First, let's talk about what that term diameter means. Let's make that really clear. What does diameter mean?
It means straight through the center of a circle.
Yeah, right across. From one end to the other, going through the center point. Basically the width, the longest width of the circle. That's it exactly. So let's come back to graphing this here in just a moment. But I do want to point this out as well because it might be helpful for some students. I don't know. On my cheat sheet, I want everybody to go to that rules for SAT math document. And I know we focused on the first two rules, which is just enough for, like, good heavens, like so many of the questions. But I do get into some more specific concepts in that SAT math cheat sheet. Word problem systems of equations, trigonometry, statistics, lots of stuff. But if you go down to basic concept N, there's 4 equations you need to know for this test. Okay, that could be helpful. One of them is the equation of a circle. Okay, on the old SAT, you had to memorize them for sure. But there's the equation of a circle. It's in the form x minus h squared plus y minus k squared equals r squared. And I want to point out what all this means. The h value is the x value of the center point of the circle. It's not really on the circle. It's like the bullseye in the middle of the circle. And the k value is the y value of the center point. And then the r value is the radius of the circle. I just want to kind of point that out and show what things mean here, sort of in this equation. So you can sort of like, if you know the equation of a circle, if you have that memorized, you can sort of like interpret the equation, figure things out. But I think just a much safer path here on this question that we've got in front of us is just graphing this thing in Desmos. So let's just do that. But I want to point that out. You can reference that in the cheat sheet if you see a question on that where you need that or you want to figure it out another way. Let's graph this circle. All right. The toughest part is just entering this in. Mm-hmm. Make sure you use those parentheses properly. X minus 5 squared. Squaring everything in parentheses. And Emma Maria, make sure you're practicing entering this in as well. So y minus 3 squared equals 16. Hey, I got a circle here. Ruby, you got that entered in?
Almost.
Okay. All right. So you see a circle. And remember, let's not lose sight of the question here. We're solving for the diameter of the circle. So that's like the length from one end to another, crossing right through the middle point of the circle. Just count. Like, don't even try to do a calculation here. Just like count how many units are from one end of the circle to the other. So like from this end to this end across. So let's count them. And how many units is that diameter? And Emma Maria, why don't you try to do it on your own as well?
16?
I don't have 16 units.
8?
Let's count. I want you to go to the screen share. We're going to count together. Go to the screen share. Did you get roughly the same circle that I got?
I think so. Yes.
You did. Okay. So we're literally just counting the units from the bottom to the top of the circle. That's 1, 2, 3, 4, 5, 6, 7, 8 units from the top to the bottom. That's a diameter.
I have a question.
Yeah.
So before we had the like calculated and stuff. So isn't it equals r squared?
It equals
so
r squared.
Wouldn't you just assume that 16 is the diameter?
Well, no, not exactly, right? Because, and this is where like it's so easy to get tripped up when you're like thinking in algebraic terms and like in trying to interpret the equation. You're absolutely right. 16 is r squared. That is 100% correct. 16 is r squared, right? Because the equation is x minus h squared plus y minus k squared equals r squared. So
Yeah.
yes, so 16 is r squared. But that means what's the radius?
Oh, just
what's the radius? Tell me.
See.
What's the radius?
8.
No.
Or no, the radius?
Yeah.
Sorry. It wouldn't.
If 16 equals r squared, which it does, that's true.
Oh, 4.
The radius is 4, right? Because you got to take the square root of both sides.
Yeah, no,
so
I see.
The radius is 4. So once you know the radius to solve for the diameter, right, the radius is just, or the diameter is just 2 times the radius, right? It's not the radius squared, 2 times
that makes
sense.
Right.
But that's where it's easy to get tripped up if you're trying to interpret the equation. Does that make sense?
Mm-hmm.
Lots of students are going to answer C here. Lots of students. Or some students are going to solve for the radius. Like, oh, sweet, radius is 4. And then just answer that losing sight of the question. But if you just graph the circle and you see it and just count the units, it's like, oh, that's 8 units. So the diameter is 8. That's the easiest way to do it. Does that make sense?
Yes.
Good.
Yeah.
Graph it and see it, and then you avoid a lot of the traps. Just make it concrete. Don't be an algebra hero. I tell students all the time, don't be an algebra hero. Even if you know the algebra, like just keep it simple. The fewer steps you need to do, the more likely you are to get it. Questions about that?
No.
All right.
Mm-hmm.
All right. We got some more circles coming up. They do like the circles on the digital SAT math. All right. I think we are on Emma. Go and read question 24. When you see that on your screen, please, Emma.
Which of the following equations represents a circle in the xy plane that intersects the y-axis at exactly 1 point?
What are we solving for here, Emma?
I guess we're just trying to find which equation.
Uh-huh.
I guess so we have to... I guess we have to put all of them in the calculator.
Yeah. And then the right answer will do what?
Intersect the y-axis at only 1 point.
At only 1 point, and that's it, right? Don't try to interpret these equations. Don't try to like graph it. Just punch them into Desmos and see which circle intersects the y or touches the y-axis at 1 point. That's it. Does that make sense?
Yes.
I want you to do this on your own. Anybody watching the recording as well, do this on your own. We'll do it together here in just a moment. But first, do it on your own. So Ruby and Maria, I want you to do it as well. Just punch these into Desmos. And let's see which one intersects at exactly 1 point. Try it on your own. And we'll test the right answer here together in just a moment. One of the nice things about Desmos, you don't need to always like rewrite the whole equation. You can just like edit one of the equations. You know, the only difference between A and B is you've got a -4 instead of a -8 in the parentheses. So you don't have to rewrite the whole thing. Just replace that -8 with a -4. We should get one circle that intersects the y-axis, the one going up and down, at exactly 1 point.
Okay.
You got it, Emma?
Yes. I think, is it B?
Well, let's test that.
I got a different one than that.
What did you, who was that, Ruby or Maria?
Maria.
Maria, yeah. What did you get?
I got C.
Okay. Ruby, you still working on this one?
Wrong.
You still working this one, Ruby? Emma, you said it's B.
I got the same as Maria.
Yeah, okay. Let's start with the answer choice B, Emma, because you got B. Let's punch that in. So go to the screen share. I'm just going to enter it in. X minus 8, close parentheses squared, plus y minus 4, close parentheses squared. Trickiest part's just punching it in, It's not even that tricky. There we go. Okay, I see a circle. Now, I don't think it's B, Emma.
Yeah,
Why isn't it B?
X-axis.
That's the x-axis.
I think I typed C in wrong, and that's why.
Oh, okay. Okay. Well, let's try C. Because I think Ruby and Maria, you guys got C, right? So we'll just edit.
Yeah.
Answer choice
Yes.
B. Again, you don't even need to rewrite the whole thing. The rest is the same. There we go. I think it's choice C. Intersects the y-axis at 1 point. By the way, what point is that intersects at? You see it?
0, 9.
Yeah, 0, 9. That's the y-axis, the one going up and down. And that's the answer.
Yeah.
Answer choice C. Questions about that, or is that pretty clear now?
Yeah.
Okay. Again, the trickiest part really is just like entering it in accurately, right?
Yeah.
You see why you got to practice, right? You don't want to be trying to figure this out like on the day of the test. You got to be really fluent with just entering things in accurately on the Desmos. But if you can do that, you're just graphing it and seeing it. There's no algebra involved here. You don't need to. You don't need to interpret that equation. Just graph it. Questions about that? All right, really good job. I think we got one more circle question. This one's a little trickier. Aha. All right, Maria, you are up. Go and read 21 for us, please.
A circle on the xy plane has a diameter with endpoints 2, 4, and 2, 14. An equation of this circle is x minus 2 squared plus y minus 9 squared equals r squared, where r is a positive constant. What is the value of r?
Ooh, what are we solving for here, Maria?
I mean, just what r is.
What r is, what the radius of the circle is. Does that make some sense?
Yeah.
Yeah.
Mm-hmm.
Now, we could do this again. If you know the equation of a circle, if you're really comfortable with it, we could like find the center point of the circle. Like we got to interpret that equation correctly. We find those endpoints, kind of graph it on your own on paper. It's going to be tricky though, because we've got like one of the units is like 2, 14, one of the points is, and it's going to be a big graph. I mean, you could do it. There's a path there. But there's an easier way to do this, just using Desmos. And that's by just testing values for r, right? Like we'll keep this whole left-hand side of the equation the same and just play with values for r until we find an equation with an endpoint 2, 4 and 2, 14. And then we'll just see what the right answer is. Does that make sense, how we can just kind of plug in values for r and it'll kind of like we avoid a lot of operational errors? Does that make some sense?
Yeah, that makes sense.
Okay.
But how do you know which like intervals of numbers or where should you start?
Yeah, well, it's going to
like
be, it's not going to be a negative number, right? Because the radius is going to be negative. It's going to be a whole number, you know? It's going to be a whole number. So we'll just play with them and just kind of look at it like a little experiment and see what happens. Okay, we're going to see this strategy applies on a lot of different kinds of questions that are coming up here in just a minute. But let's start by just entering this in. We'll enter in the left-hand side in Desmos. And Ruby and Emma, I want you guys to try to play with some values for r and see if you can figure out what the right answer is here on your own. And Maria, we'll do this one together here on the screen share. So we got x minus 2 squared plus y minus 9, close parentheses, squared, equals some number squared. We don't know. I'm just going to start with 1. Okay? We'll just start with 1, see what happens. All right, does that give us a diameter with endpoints 2, 4 and 2, 14? Maria?
No.
No, not even close. So that's not going to work. Those points aren't even on that circle. I don't know. Let's try 2. So I'm just literally replacing the 1 with the 2. You don't have to rewrite the equation. I'm just editing the r value in the equation. Does that give us an endpoint of 2, 4 and 2, 14?
No.
No, it's not big enough yet. All right, let's try 3. Does that give us a diameter with endpoints 2, 4 and 2, 14?
No.
Not yet. We're not getting there, right? And like here, like the y value is, that's 2, 12 and 2, 6, which is not big enough yet. Let's make the radius bigger. Try 4. Does that give us a diameter with endpoints 2, 4 and 2, 14?
No.
Not yet, but we're getting there. I'll bet 5 works. There, the radius is 5. Does that give us a diameter with endpoints 2, 4 and 2, 14?
Yes.
Heck yeah, it does. There's 2 comma 4. There's 2 comma 14. Just play with numbers. If you need bigger numbers, punch in a bigger number. If you need a smaller number, type in a smaller number. How long would that take if you're just testing values sort of on your own? How long would that take using the Desmos calculator?
Probably like a minute.
Not even. And the longest part is just entering the left-hand side of the equation. It's fast. It's accurate. You're going to get it. And there's nothing to like misinterpret if you're just thinking in concrete terms and just seeing it. Does that make sense, Maria?
Yes, it does.
And I get your hesitation. You're like, but I don't know what R is. Like, what if I pick a number that's too big? Well, then pick a smaller number. What if I pick a number that's too small? Then pick a bigger number. Like you're literally just like, you just adjust it. It's not that difficult.
Well, I mean, I think what I meant was like looking at your H and K values.
Yeah.
Like say they were a lot bigger.
Yeah.
Would you know how would you notice would you know to start at like 20 or something or?
Oh, I see what you're saying. Yeah. I haven't seen, man. I mean, I can't think of any question I've seen where the radius is like even bigger than a whole number or they're like a single digit number. I can't think of any. I'm not saying it's not possible. Could you have a radius of 20? Maybe it'd be huge. But I think they're expecting a lot of students to solve this sort of like manually on paper. So like they're not going to give you crazy big values. It's going to be a relatively small radius value. I can't think of any exceptions to that.
That makes sense.
Yeah, it would just be nuts if the values were that much bigger. It's still doable with Desmos, but again, I don't think most students are going to try to solve it that way. Most students are going to try to like graph this thing, but there's just so many little traps as you try to draw out your H and K values and like, this is going to be tough doing it manually, but it's a breeze with Desmos. Questions?
Yeah, makes sense.
Yeah, good question. Really good question. All right. And I think I do have an equation of a circle question for you guys in the homework as well, so you'll get a little more practice with that on your own as well. All right. We got some more high-level difficulty questions coming up here soon. There we go. This one's no problem. Okay, we are on Ruby. Ruby, go ahead and read question number 18 when you see that on your screen, please.
The solution to the given system of equations is xy. What is the value of y?
What are we solving for here, Ruby?
The value of y.
We're solving for the value of y. And I'm guessing a lot of students, when they see this question, are like, oh, system of equations, sweet. I'll just do the old substitution method or the old elimination method. And like, I've done system equations before in algebra class, right? I mean, would you be inclined before this course to solve this using like elimination or substitution?
Oh yes, that's automatically what I thought.
Don't do that. Don't do that. Don't do that. I can't think of one exception to this. Every system of equation question I've seen, you can solve by graphing. Because these are going to be 2 lines right here. I mean, is that clear? These graph as lines?
Yeah.
And even if they weren't lines, it was like a line and a parabola, or heck, even 2 parabolas potentially. Like, you just graph them. And the solution is going to be the point of intersection between those lines. Does that make sense?
Mm-hmm.
Don't do the algebra. Rule number 1, avoid complex algebraic operations whenever possible. Rule number 2, use that Desmos calculator. You combine them and you're golden. Let's just graph them. Emma and Maria, I want you to graph these on your own. Ruby, we'll kind of do this together on the screen share. Heck, Ruby, you can even graph it on your own. I'll do it on my end on the screen share.
Okay.
As well. You don't even have to put them in y equals mx plus b form. Just leave them as they are. There's one line. I got 2 lines. I got a point of intersection. Ruby, let me know when you're there, when you got 2 lines. And Emma and Maria, also let me know when you got 2 lines that you see intersecting.
I have 2 lines.
You got 2 lines?
I have 2 lines.
All right. You still working on it, Ruby?
I was watching you do it.
Oh, you're watching. Yeah, okay. Okay, good.
Yeah,
I think like you could do this, right? This is no problem, right?
No, yeah, I was. Yeah, you just said watching.
Okay. Yeah, I got you. Sorry. Okay, so look, now the tricky part here is like, okay, where exactly do they intersect, right? Because they're not parallel. Like, I mean, clearly they're intersecting, but like they're pretty close. They're almost parallel. So you might need to zoom in. Use that zoom in function. Do you see the point of intersection on the screen share, Ruby? Yeah, and it's right here. You got to zoom in a little bit to make it really clear. So the solution, or the point of intersection, is the point 7, -2. Is that clear?
Yes.
Okay, now we got to be careful here. What are we solving for with this question?
The value of y.
What's the right answer here?
-2.
-2. Answer choice A. It's not 7, that's the x value. So it's really a question of like just entering this in accurately and then just knowing the difference between your x and y values. And that's it. That's it. How long should that take if you're using the Desmos calculator? How long would that take?
I mean, 30 seconds. I don't know.
Maybe 30 seconds.
Yeah.
How long would it take if you're doing a system of equations like elimination method?
A long time.
A long time. And think of all the operational errors that like you could run into, like just losing a negative sign. Like, and here if you're doing this elimination method, like you've got to multiply both equations by something. Like you got to multiply the top equation by like 2 and the bottom equation by 7 or something like that to get rid of the y values, or to get rid of the x values, you multiply the top equation by. You just multiply the bottom equation by 3. That would work. But still, like you're doing a bunch of arithmetic and a lot of steps. It's just you're guaranteed to get it if you just graph it. Anytime you see a system of equations, just graph it in Desmos. Questions about that?
No.
It is ridiculous how easy this test is if you can use Desmos. Like, it's just ridiculous. It's blown my mind constantly. Like, and a lot of students they're just going to go to math class mode. They're like, okay, elimination method, and they go through all the steps, and they're going to jack something up along the way, right? Like, that's all of us. That's me too. The more steps I'm doing, the more likely I'm going to make a silly mistake. I make them all the time. It's really hard to mess up with Desmos. So make it your instinct, your first instinct. Say, can I graph this? You'll find the right answer. You'll find it fast. All right. Let's do a few more. Oh. All right, Emma, you are up. Go ahead and read question number 19 for us, please.
One of the equations in a system of two linear equations is given. The system has no solution. Which equation could be the second equation in the system?
What are we solving for here, Emma?
I guess we're trying to find the second equation in the system.
Yeah, the second equation in the system, but notice this system has no solutions because they tell us that. Is that clear? Right?
Oh, so we're trying to find which one of these has no solution.
Which one of these gives us no solution to the system? You got to understand that. Does that make sense?
Mm-hmm. Yes.
Okay. Do you have any idea how to use Desmos to solve this?
I guess kind of how we did the last one and just put them both in.
Very similar. Yeah, we're going to graph both equations, but which line are we looking for? If the system has no solutions, what are the lines going to look like if the system has no solution?
The lines that are parallel.
The lines that are parallel, they're not going to intersect, because if they intersect, there's a solution. But if there's no solution, we're going to get parallel lines, and that's it. Does that make sense?
Yes.
Like if you can interpret what that means, you're golden here, and we're just doing Desmos. So let's do it. Okay. All right, Ruby, Maria, you guys enter these in on your own, on your end?
Yes.
All right. And then Emma, we're going to do this together. Clear this. We'll get the first line. All right. I don't even see that line. Got to zoom out a little bit. There we go. There's a line. And the second line. Don't even have to put it in y equals mx plus b form. Just leave it as it is. Desmos does the work. Y equals 18. So we enter answer choice A here. Whoa! What do you think about answer choice A? There, Emma. That's interesting, right?
Are they on top of each other?
They are on top of each other, right? It's like the black line disappeared, right?
Yeah.
You see that? You can zoom out and be like, hey, where'd they go? They're on top of each other. Does that have no solution?
I guess it has like an infinite solution.
That has an infinite number of solutions. And by the way, like they could adjust this question and make a different question by saying that, right? If they said the system has an infinite number of solutions, then it would be A.
Yeah.
Because it'd be the same line. These are the same line. Now, again, you look at these equations, they look like different equations, but if you put them both in y equals mx plus b form, you're going to get the exact same equation. Look at it, right?
Yeah.
I mean, you add 6x to both sides, you get the exact same equation. No big shock that the lines are overlapping. It's the same equation, but it's not answer choice A. Does that make sense, Emma?
Yes.
Okay, great. Let's try answer choice B. And the only thing we need to do, we don't need to rewrite the equation. We're just changing the 18 to a 22. There we go. Oh. How's that looking?
I think it's parallel.
I think those are parallel as well. I think those
Yeah.
are parallel. That looks good. It's probably B. Let's double check the others. Okay?
Okay.
We got time to do it. This doesn't take long. So I'm just adjusting the equation. That's 12x plus y equals 36. Yep. Do we have a point of intersection?
Yes.
Yeah, we do. So it's not C. Let's do D. Again, we're changing the 36 to an 18. That's all we're doing. Oh, my goodness. It's not difficult to test these.
Yep.
Point of intersection, so it's not D. We can confirm.
Yep.
That's answer choice. B. Ruby, Maria, were you able to solve this as well, just using Desmos?
Yes.
Okay.
Yes.
Okay. Great. Now, if you're doing the algebra on this, and you could put all the answer choices into y equals mx plus b form. It's not too complicated. It's really not. And you'd want to see the same slope and a different y-intercept. And that would give you a system with no solutions. But it's just so concrete, just entering the Desmos and just seeing which one gives you no point of intersection. And there's just nothing to mess up. Questions about this? Are we good?
I think we're good.
I think we're good too.
I'm good.
Great. All right. Aha. This is a little different. We got some inequalities here. All right, Maria, go ahead and read question number 12 for us, please. Let me see that on your screen.
The point x53 is a solution to the system of inequalities in the xy plane. Which of the following could be the value of x?
Ooh, what are we solving for here?
Just what the solution to x would be if y is 53 with the given equations.
Yeah. Do you know how to solve this algebraically? Is that pretty clear? Are you comfortable with that, or maybe not so much?
Yeah, I think I'd be pretty comfortable with that.
Okay. Yeah,
I don't know. It's been a few years.
Yeah, I got you. I mean, there's a way to do it. I think you could, and I'm not certain, but I think you could plug in a 53 for y into the bottom inequality and solve for x, but then we got to keep into account that y is greater than 14. I'm not certain. I'll be honest. I'm not how to solve that algebraically. Some students might be comfortable with it. We don't even need to go there because Desmos graphs inequalities. It graphs inequalities. So let's open up Desmos. And right now, ladies, just watch kind of how I do this on the screen share. I'm going to clear these out. You can practice this on your own for homework. And for homework, by the way, you're just redoing the questions we've done and a couple, 3 new ones is all you're doing for homework. Just getting really comfortable going through these processes here. So I'm entering in y is greater than 14. You see the greater than and less than signs there in Desmos. Is that clear on the screen share?
Yes.
You don't have to solve any inequalities. You just graph them in Desmos. Okay? And notice that gives us, we've got a line that roughly at y equals 14, just above it, essentially, the dotted line. And everything above that is shaded blue. Those are all solutions to y is greater than 14. That should make sense, right? Because y is 50 or 100 or 150 or anything above there, that's all a true statement. Y is greater than 14. Does that make sense? Maria, does that make sense?
Sorry, yeah, it does.
Yeah, okay. Let's graph the second inequality. Again, we're just punching it in. So it's 4x plus y. Don't even need to put it in any fancy form. Now, that's less than 18. Okay. Now we've got another shaded region here in Desmos. Notice this one's shaded in green. Okay? But this is a system of inequalities. So let's talk about where the solution set to this system is. Maria, is it clear to you where the solution set to the system of inequalities is? Do you see it or no?
I think so, right? You're given that y is 53. So you're assuming X is like, I mean,
well, let's talk
what
about
do you
just
mean?
where on the graph, like which shaded region is the solution set. Do you understand my question?
Yeah, wouldn't it be in the non-shaded solution?
No, that's outside. That's in neither inequality right here. That's in
Oh, I
neither
see.
inequality.
I mean,
and then
I guess
the solution set to in a system of inequalities is where both inequalities overlap. So look on the screen share. It's this region right here, the dark green, where both of them overlap. Does that make sense, Maria?
Yes.
Ruby, Emma, does that make sense? Where that's the solution set in the dark green, where both systems overlap.
Yes.
Okay. That's kind of essential here to understand this question. I'm going to refresh my whiteboard real quick. Hold on just a second. Okay. All right. So now we've got to find out which could be a value of x. Okay. We've still got to interpret that, right? Now it tells us in the question the point x comma 53 is a solution. So we know the y value's got to be 53. Okay. So I'm going to zoom in a little bit and kind of find out where the y values are like 53. I was like up here. Okay, so there's like 50, it's like 52. I'm going to zoom in a little bit more. Okay. There we go. So the y values are going to be, there's 51, 52, 53. Does that make sense where we are here on the graph? On the y-axis for y is 53. And so I'm going to go to this point right here where the y value, there we go. The y value is 53 there. What's the x value at that point where the y value is 53?
I guess pretty much -9.
Yeah, roughly -9. I mean, it's -8.75, which means that anything less than that in this region over here could be a possible solution. Anything less than -8.75. Does that make sense? Does that make sense? Did I lose you?
It said that she just left the meeting.
Oh, no.
So...
Okay, she might have just pressed a button. Ruby, does that make sense? Why we know that at that point, x needs to be something less than -8.75. Does that make sense?
Yes, because it has to be whatever's inside of the
whatever's
area.
inside the region to the left, right?
Yeah.
So it could be anything less than -8.75. That's enough to get us the answer. What's the right answer here?
-5.
No. -5 is not less than -8.75. -5 is greater.
Oh, yeah, -9.
-9. Does that make sense?
Yes.
Yeah, that's a little tricky.
Sorry,
right?
I'm
just,
not.
No,
I'm
you're
not
good.
sure
It's
what
a
happened.
common mistake. It's really easy to misinterpret there because 5 is smaller than 8.75, but -5 is greater than -8.75. Does that make sense? We need something less than -8.75. So that would be answer choice A.
Okay.
Does that make sense now? -5 would
Yes.
be over here, like where x is -5 would be over here in the blue region, which would satisfy one of the inequalities, but not the other, not the system of inequalities.
Okay.
Questions about that, or does that make sense?
That makes sense.
It's still a little tricky even with graphing with the Desmos, but as long as you can kind of keep those, the negative values straight there and what that all means, it's just a question of graphing it and seeing it. Is it clear B, C, and D won't work now? Is that clear? That's all in the blue region, B, C, and D.
Yes, that makes so much
Yeah,
sense.
but we need the dark green region, and that would be -9.
Okay.
Questions about that, Ruby or Emma?
No.
Yeah. Okay.
Nope.
Right.
I had to rejoin, so sorry if I missed anything.
Oh, you're good. You're good, Maria. Yeah, I'll go real quick with you as well. So,
I understand it.
You got it? Yeah. Do you see
Yeah.
why the right answer is A?
Yes, I do.
Awesome. Yeah, just graph it and see it. I mean, then again, there's an algebraic way to do it. It might be I probably might get tripped up on it. I might, but when I just graph it, I'm like, oh, it's got to be -9. There you go. And just no operations. You just see it. So, all right. Let's do a few more. You guys okay? All right. So, Emma, go ahead and read question number 21 when you see that on the screen.
In the given equation, b is a positive integer. The equation has no real solution. What is the greatest possible value of b?
Oh, this is a tough question. I saved some of the tougher ones for the end here. What are we solving for here?
The greatest possible value of b.
The greatest possible value for b. And you see b here in the equation. It's this guy right here, right? That's the coefficient in front of the x value, okay? We don't know what b is, but we're trying to find the greatest value of b. That gives us no real solution. Is that clear?
Yes.
So if we graph this, what's this going to look like on the xy axis. Are we going to have any x-intercepts? Are we going to have one x-intercept? Are we going to have two x-intercepts? What's this going to graph like if there's no real solution? Let's talk about that first.
I'm not sure.
Yeah. We've done some questions like this before, didn't we? Because sort of in the first part of the course where we had a quadratic equation. And the question was, how many real solutions are to this quadratic? Right? Do you remember that one?
And it's the one that doesn't have an intercept.
And that was the one without x-intercepts. Does that make sense? So you got to kind of have that in mind here when you consider this question. That the right answer for B, we're looking for the greatest possible value for B that gives us no x-intercepts, right? Because an x-intercept would be a solution to that equation. Does that make some more sense?
Yes.
Okay. So let's graph this. Okay, now you might be like, well, Mr. Tui, how do I graph this? Because I don't know what B is. Well, this is like that circle question where it's like, we're just going to play with some values. And we're going to see what happens. Because some of the values for B might give us a solution or two solutions, and some might not give us any. We're going to look for the greatest value B that gives us no solutions. So I'm just going to start entering this in. Right now, just stay on the screen share. So let me show you what this looks like. So I'm not going to leave a value for X or for a value for B. I'm just going to make B equal 1. So I'm just going to leave it as plus X. We'll put some stuff in place of B here in just a minute. But right now, we'll just make B 1. Minus 676. Does that make sense what I'm doing here so far, Emma?
Yes.
Okay. All right. I need to zoom out clearly because I don't even see anything. Where the heck is that? Oh, there it is. Whoa, that's way down there. Woo, that's way down there. We got a y-intercept of like, I don't know, 700 or something like that. I'm going to zoom in a little. Got to zoom in and out with the Desmos a little bit. Happens. That's all right. Okay, there we go. Do you see the parabola on the screen share?
Yes.
Okay, great. How many solutions are there to this equation right now?
None.
None. Because there's no x-intercepts. Okay, great.
Yeah.
We've got a pretty small B value, and we're looking for the greatest possible value for B. So we're going to have to bump up the B value, the value in front of the x. Does that make sense?
Yes.
Okay. Give me a value for B. Let's just play with numbers and see what happens. Give me a value.
5.
Okay. Oh, it's gone up just a tish, just a little bit.
Okay, so we're looking for something like really
This is going to be
big.
bigger than that. Yeah, give me another value. There's nothing to mess up here. If we need, give me a value.
10.
10. All right. A little more of a tish. Give me another value. Be bold.
200.
200. Oh, that's a little too big there. That's all right.
Oop.
Let's do a smaller value.
Okay.
Right? Because that gives us two solutions there, right? Does that make sense?
Mm-hmm.
Give me another value.
50.
Oh, that's close. I'm going to zoom in a little bit. No solution there for 50, but we're getting close to that x-axis. Is that clear?
Yes.
We're much closer. Bump that up a little bit. Let's see if we can get closer.
Let's see. 70?
Oh, way too big.
Oh, way too
So it's
big.
going to be closer
Okay.
to 50, right?
Yeah. So like 55? Nope, too big.
Still too big. So it's between 50 and 55. 51. Ooh, okay. No solution there. Is that clear?
Yes.
What about 52?
52.
Oh. Does 52 give us a solution?
Yes.
Yes, it does. So what's the right answer have to be?
51.
It's got to be 51. That's the greatest possible value for B. That gives us no solution. It's 51. Is that clear?
Yes.
Okay. Don't be afraid to bump it up, right? When we enter that 200, it's like, oh, yeah, that's too big. Well, I'll pick something smaller, right? Oh,
Yeah.
70 is too big. All right, pick something smaller. Right? It's just trial and error. It's by far the best way to do this question. There is a way to do this with the discriminant, setting up an inequality. It's super obnoxious. It's so involved. And you just don't need to do it. But if you can graph it and just look at these questions like a little experiment with values, that's it.
Yep.
You'll find it. But this is a very high level difficulty question. Very few students are going to get. But if you can use the Desmos, it's not that difficult. You're going to get it. It's not going to take that long. Does that make sense, Emma?
Yes.
Okay. Maria, got any questions for this?
Nope, I don't.
Okay. Now, this is one of those questions, right, where the values could be a little bit bigger here. That's okay. You got the time to do it. I mean, just be bold. And if you need a bigger number, pick a bigger number. If you need a smaller, pick a smaller number and just kind of play with it until you find the value that meets the requirements of the question. In this case, it's 51. Okay. One more question coming up. I don't remember which one this is. We'll see. It'll be a surprise for all of us here. Aha. This is a tough one, too. But I think we can get it. All right, Maria, go ahead and read question number 21 when we see that on the screen, please.
In the given system of equations, A is a positive constant. The system has exactly one distinct real solution. What is the value of A?
Oh, my goodness. What are we solving for here, Maria?
We are solving for the positive solution to A.
The positive solution for A. Yeah, this is a tough question, especially if you're doing algebra. It's really tough. I mean, would you have any idea how to solve this algebraically? Or not so much?
I mean, yeah, I think
you
so.
Could? Okay, I mean, your algebra's strong. That's good. You can do it. I think this involves the discriminant again. Right?
Yeah, that's what I was going to say. I think I'd use the discriminant.
Yeah. But it's just so time consuming. There's so many steps and so many little traps.
Also, I never remember like the exact ways to do stuff like that.
Yeah, right.
It's been over a year for me. So.
Exactly. Just don't even go down that path. We're going to graph this. Do you see how we can just like test values for A to graph this and find the value for A that gives us one distinct real solution? Do you see how to do that already? Is that path becoming clear or no?
Yeah, it's clear, but would you plug in that negative 1.5 to the y or no?
Well, I say just graph them separately, right? Like this is going to graph as a horizontal line and this is going to graph as a parabola. So I just graph them separately. You could combine them. There's a way to do it, but like don't go there. Just draw the two lines. Just do the two lines.
Okay.
So let's do this together here on the Desmos. And Emma, you can just watch right here because we're going to have to do something similar to the last one. We're just going to be like playing with values. So y equals negative 1.5. That's the first line. Look at that. Horizontal line going through negative 1.5 on the y-axis. No big surprise there. Does that make some sense?
Yeah.
Okay. Let's graph the second. X squared plus 8x. And then we don't know what the a value is, but look at this right now. I guess the a value would be 0 here at this point. Is that clear, Maria?
Yeah.
The a value is 0? Okay. How many solutions do we have right now to the system?
2.
We got 2 because we got 2 points of intersection right here, right? For this current a value. So do you think we need a bigger a value or a smaller a value? Do you have any idea?
I think my inclination would be smaller.
Yeah, let's try it.
I don't know.
Let's try it. Give me a value for a.
I guess we'll just say like 3.
Negative 3? Or do you mean positive 3?
Well, I mean, I was thinking negative because of the y, but honestly, I'm not.
Let's try it.
Sure.
Let's do negative 3. Okay. Do you know if that's going up
so
or
there's
down?
still 2.
What's that?
So I guess you'd go with the positive.
Yeah, let's try positive. I think the positive value is going to bring up the parabola. In fact, it does, right? Because negative 3 dropped it. So give me another value.
So go with positive 4.
Plus 4. Okay. Oh, see, it's going up, right? No big shock there, right?
Okay.
That value at the end is going to just drag up all the other values by 4 units.
So it's going to have to be a way bigger number, though.
Yeah. Give me another value.
Okay, so I just jumped like 16 or something.
Yeah.
I'm not sure.
That's all right. 16. Oh, that's close. That's close.
So wait, you want it on the y that was given or the regular y-axis?
Well, this is the y-axis right here. That's the y-intercept right now.
I mean x, sorry.
That would be the x-intercept. But we're looking for the solution to the system of equations. So you tell me, do we need it intersecting with the x-axis or do we need it intersecting with the line?
The x?
No. It needs to intersect with the line because that's the only way it's going to satisfy the system.
Oh, I see. Yeah.
Right? Does that make sense?
Mm-hmm.
Yeah. So we got to drop it a little bit. So we need something a little bit less than 16?
I guess 11.
Let's try 11. Oh, too small. Give me another number. There's nothing to mess up here.
14.
Yeah, 14. Oh, that's so close. But it's got to be a little bit bigger. We're almost there.
15.
Let's try 15. Oh, wait, what did I do? Oh, that's 115. 15. Oh, that's a little bit too big. So it's
Okay,
it's
I
got to be
guess we'll
something
say
between
14.5.
Let's try 14.5. We'll get there. Oh, look at that. How many solutions we got?
1.
One solution right there. What's the right answer?
-4.
No.
Well, is that not what A would be?
What are we solving for?
A.
We're solving for the value of A. And what was the value of A?
Oh, 14.5. Sorry.
14.5. That's the answer. Does that make sense?
Mm-hmm.
Okay. That's a little tricky though, right? It'd be kind of tragic going through all those steps and like testing all those values and then like, oh, there I got it. And then you answer what the X value is or what the Y value is. But that's not what they're asking. It's what's the value of A. That gives you one distinct real solution. And that value is 14.5. Questions about that? Does that make sense?
Yeah.
Most of the time it's whole numbers. Here it is a little decimal, but it's not that bad. I mean, like, just like, oh, it's between 14 and 15, 14.5, and you'll get it. Questions about that?
Mm-mm.
Okay.
Nope.
That's still tough, but like so much easier than trying to do the algebra. So much easier. And with a little practice, like make this your instinct, just graphing it, seeing what the answers are, and you got it. Okay. That's all I got for today. So for homework, and I'll send you links to the recording if you need to review any of the answer explanations. I'll also send you the problem set that you need with all the homework. And again, for the homework, you're just redoing the questions we did today on your own. You got to practice it because you got to make this your instinct. When you see questions like this, don't go into algebra mode, don't go into math class mode, don't do the operations, just graph it and simplify it. And then there's 3 new homework questions as well. But I think if you understand the questions here that we've gone over today, I think you're going to be good on the homework questions. If you're not able to solve the homework questions, that's okay. We'll go over them at the beginning of our next session as well, those 3 homework questions. And then the next session, we'll jump into the plugging in values, strategy, and functions for the next session. You always have any questions at the moment?
No.
All right. How are you feeling?
Actually,
Go ahead.
I have like an off-topic question. So
Sure.
you said you have a YouTube channel.
Yeah.
Do you do other maths? Like, do you do pre-calculus by any chance on your
I
YouTube?
don't do pre-calculus. No, I've got a bunch of other.
Okay.
I got
good.
a bunch of other like TSI, AccuPlacer, and CLT and stuff. Yeah, but
Okay.
but not pre-cal. No, it's funny. Like I've had some students that have been like, Ms. Chewy, could you tutor Algebra 2? And I was like, yeah, I mean, I teach SAT. I should be good in Algebra 2. And I looked at some of the stuff. And I was like, I don't know how to do this.
Yeah.
Yeah.
Algebra 2 goes in deep. It's ridiculous.
There's just not that much Algebra 2 on the SAT. There's not, and especially if you're using the strategies I'm teaching you, like.
Well, I feel like I wouldn't have known how to do my PSAT
Yeah.
this year without what I'd gone through in Algebra 2 last year. So.
Yeah.
I feel like
Some of it's helpful, but I'm telling you don't even need that much Algebra 2. Again, especially approaching the questions we're approaching them now with like using the Desmos calculator and like you'll see, especially when we get to the next day of the course, like you just don't even need that much algebra. It's all about making things concrete with actual values.
Yeah.
It's about thinking about the questions the right way and using the right strategies. It's just a different animal than math class math. Does that make sense?
Mm-hmm.
Yeah. So
Okay.
that'll be clear as we work our way through the course. But
Okay.
but no pre-calc.
Well, thank you.
Thank you very much for your participation today, and feel free to reach out if you have any questions. You got my email, and I look forward to seeing you ladies next Saturday, 10 a.m. All right.
Okay.
Thanks so much.
Bye.
Have a great day, and see you soon.
Bye.
Bye.
Thank you. Bye.
Thank you. Bye.